Continuously variable valve timing changes the valve timing of an engine. An engine is essentially an air pump, and as it pumps air, its efficiency changes as a function of its engine speed. At high engine speeds, the valves will open and close at a different time than they will at low engine speeds. With old designs, engines typically had fixed valve timing. So we had to pick a timing that was a compromise. It had good low-speed breathing and good high-speed breathing. But we're able now to actually tailor the timing of the valve. So at low speed, we open it and close the valve at different timing than the high speed. And this is the device that does it. It's attached to the camshaft which runs it through the engine, but it's spun through the chain drive system of the engine, and the device is simply constructed of different vanes fed through with oil pressure, and the pressure feeding oil into those into the cavity of the VVT device actually changes the cam's orientation relative to the sprocket that's driven by the chain. So for any given engine speed, we can command the camshaft to be in a little different orientation than it is based relative to the sprocket. As an example, very low engine speed, 2,000 RPM, when the piston's at the bottom of its travel and starts to go back up the cylinder, it will quickly start to push air back out of the intake valve, and you want to close it right at that point. But at high speed, air has a lot of momentum, and it's still traveling and pushing its way into the cylinder past the intake valve, even though the piston has gone significantly up the cylinder bore. At that point, you want to close the intake valve much later in the cycle, so you can take advantage of maximizing the volumetric efficiency, getting the most air into the cylinder, and making the most power. But it also is an emissions device, which allows you to increase the amount of diluent or exhaust in the cylinder. Exhaust in the cylinder lowers certain emission constituents, and by changing the cam timing, the relationship of when the intake valve closes and the exhaust valve closes, you can control how much of that diluent is in the cylinder, which does affect your emissions. The other benefit it has is for fuel economy. At low engine speed, when you're cruising down the highway at very light load, you can reduce the effective pumping work of the engine by keeping those exhaust or the intake valves open much longer. It reduces your effective compression ratio, but the pumping work as the engine's going through its cycle is significantly less, improving fuel economy. So there's really three benefits to variable valve timing, or continuously variable valve timing. Power and torque would be one. The other is emissions constituents, and the final one is a fuel economy improver.